today we're going to be showing off the real-time plot, our UART communication, our training.
Okay.
So first off,
Sure. I'll start with the UART. All we have is a basic setup going on. We have our RX and TX lines tied together. When we transmit, the red light LED at the bottom is going to blink, and when we receive, the green light will blink.
Gotta want to check to see if it's a wall, right? And you're doing both.
Right now we're
I believe it's a toggle, correct?
yeah, we're toggling the LED
So
on and
it
off
just
whenever
checks
the
for-
interrupt service routine goes off.
It just checks for the
But we're also toggling.
So you're
the
only
LED.
toggling it based on the interrupt service routine, not whether or not you actually got what you're supposed to.
That's right, but we have tested that also. We just ended that we confirmed that we are receiving what we are. And we're also toggling one of the LEDs when we load that into the TX buffer.
Okay. So why is it? Oh, that may be. Excuse me. I should have mine turned off. Bad on me. Okay. So why is this important? Why is the serial communications important in your project?
Because we're using it to connect our two microcontrollers. We're using the UART to communicate to each other. So without that, nothing works.
Okay, and so they're communicating. How do you have a protocol already identified? Do you know how many bytes of data you're sending per?
We did,
week or?
and we're going to stick to what we have as close as possible, but it's not going to be modified because we're switching, or trying to switch the symbol with the change order.
Okay.
But we're using, it was UART, correct?
Yeah, we were already using UART to talk to our old Bluetooth module, and we're sticking with UART to talking to our fully microcontroller that's going to be in charge of our wireless communications.
Okay.
But most likely, a lot of how our data was going to be transmitted will need to be changed.
So, and your current plan is for the UART to be based, so you're going to be doing things one character at a time. You're going to send a character and wait for it to go, and then send another one and wait for it to go. When you're receiving stuff, you're going to take a character and wait, take a character and wait. Is that your current plan?
No, sir. That's just to demonstrate that we have it functional at this time.
So what is the plan?
The plan is we're going to be building an array in order
Okay.
to put our data into, and then
Okay.
we're going to be iterating through the array to send the data. That's our
Okay.
current plan.
In your interim?
The interrupt routine will only take care of receiving data. A function with some kind of loop will go through the array for loading information into the TX buffer to send it to the other microcontroller.
Okay, so on transmit, you are in fact sending a character and waiting, and sending a character and waiting.
For each character array.
Yes.
Okay. All right, so let's see what you've got.
So what you're seeing right now is the red LED is blinking whenever we load data onto the TX buffer of UART. The green LED blinks whenever we receive an RX interrupt. So if I unplug or turn off the cable here, you should see the green LED stop blinking, and the red will proceed to off. And it's actually blinking twice as fast because we're using delays to keep the LEDs on long enough to actually be able to see them right now.
Okay. All right.
And that's all we have to show you.
Okay.
Our timer in order to, or through hours we're sending off data to our server. For sake of time, I've brought it down to 2 seconds and 6 seconds. So on the red LED, you'll see it blink, or toggling on and off every 2 seconds, and the green will be every 6 seconds. Oh, sorry, the green was the 2 and the red is the 6. I had that backwards. And I've timed this up to about 5 minutes and it's stayed on accurately. So it's, the time should be just a little bit behind. Oh, sorry, just a.
That was closer to what I was measuring, about 8.
I don't think I changed it. So it's about 23.
So why do we think that is?
That is a. It was. I must have changed. not sure why that is. It was certainly 6 before, and I don't believe I've changed anything with this code. So, my mistake.
All right.
But it is working properly
Okay.
to what I have on.
Okay.
Yeah.
All right, we've done the UART, we've done the real-time clock. What else have we got?
Fun thing is,
And the coolest thing.
we just got these boards in Monday.
Okay.
We managed to get them communicating with our receiver and our transmitter, and they work well over 50 meter spec.
Okay.
If you'd like, we can go and
The plan was to go outside so we can show the distance of
of the two
Okay, so how does the demo work?
So we have the smart RF software here,
Mhm.
and it's going to send our ESET 420
Okay.
signal or packet here, and then we'll be receiving it over. And it's just random.
That's sending text. Right now you have it set to send random. Why is that?
That was the. I mean, we can change it to text and put in whatever. This is just it randomly generates the.
Oh, okay.
text at the beginning.
Okay.
Yeah. For this part of the demo, we will be transmitting from the CC1310 to the CC1111 via the smart RF software. We'll be sending a random string of characters here. We'll be sending about 100 packets. So over here, we're transmitting at 868 megahertz with a symbol rate of 50 kbaud, a RF filter bandwidth of 78 kilohertz, and a transmission power of 14 dBm. I'm going to start, and it's transmitting.
No, let's do it right now. Well, that's why we're all here. We have to go through 8 schematic sheets. We can do it. Okay, see you. Okay.
What's that bringing?
Okay, so where do you think you're sending?
The application payload.
Yep. What do you think you're sending?
We are sending CD 920034152834 E8 44 F4 0A 0D 24 AA 22 4D
Okay.
017.
If you put what you're going to transmit into a buffer and use transmit interrupts, you're much more likely to be successful in everything else that you're doing. You guys can design it any way you want to. That's a suggestion, not a requirement. So one thing, I want you guys to raise the bar on the next demo in terms of being able to show us stuff that can actually work.
Okay.
The wireless demo, given that you've only had that thing for a couple of days, I think that's great because you've been able to show that you can at least get their reference platforms up and running and doing what they say they can do out of the box. The timer, next time you get ready to show me something and you tell me it's going to take a certain number of seconds to happen,
Yes, sir.
make sure that you double check it as well with a watch, because I will. Okay? All right.
And I saw it being from the outside. They had no reference, no CBD to look
No,
at.
and I told them not, I told them that they didn't need that. So I'm.
Oh, you did?
I did.
Oh, I sure would like to see it so I know what the heck's going on. Okay.
No.
But let me ask you, last semester, you knew you were going to use this wireless protocol?
No, we actually just switched. We're about to submit our change order today.
Okay. I'll forgive you.
Cool.
But
All right,
to me,
guys.
if that had been, that would be something you would have done last semester.
Okay. Thank you very much.
Thank you.